I need to know if you remember my 3 main points from yesterday. So I'll help you out a little bit. How about that? What is a system of equations? More than one equation. Okay. What does the equation have? Remember, more than one equation, more than one variable, right? Okay. So that was my first main point, that you understand what a system of equation was. And how did we decide a system of equations was more than one equation? What were some of the hints that I gave you about that? I said a herd of cattle. I said a flock of sheep. I said a pride of lions, a school of fish, and then we said a system of equations, right? Okay, so that's how we kind of matched it in our head, okay? So then my second point was, how many equations do you have to have in a system? As many variables as you have, right? So if you have 2 variables, you need at least 2 equations. If you have 4 variables, you need at least 4 equations, okay? My third point was, where's the solution to the system? If we're talking about on the graph, where is it? It's an ordered pair that is ordered pair or ordered triple. If we're talking about 2s or 3s, it's an ordered pair or ordered triple. What's important about that point, though? It's where they cross. It's the intersection. Okay? So if we're talking about like a 2 by 2, two equations and 2 variables, that would be 2 lines and where they cross, right? Well, as you can see today, we are going to start solving systems of equations, and we're going to start by graphing. Okay, I start here for a couple reasons. First of all, because it's the easiest. Okay, second of all, is because we've done this most recently. We've done graphing recently, right? We even went back over some graphing, and you're just like, why are we doing this? We can use the calculator. Well, I knew where we were going. Okay, I knew we were coming here soon, and you'd have to know how to graph a line. So let's take some notes. Okay, consider this system. Y equals negative 2x plus 3, y equals a half x plus minus 2. For each equation, make a table of ordered pairs and then graph each line. So let's do that first. Okay? So if x is 0, what is y? Negative 2 times 0? 0 plus 3? 3. Negative 2 times 1? Negative 2. Negative 2 plus 3? 1. Very good. Negative 2 times 2? Negative 4 plus 3? Negative 1. Negative 2 times 3? Negative 6 plus 3? Negative 3. And negative 2 times 4? Negative 8 plus 3? Negative 5. Excellent. Now do the other one. If x is 0, half of 0, minus 2. Negative 2. Half of 1, 0.5 minus 2, negative 1.5. Half of 2, 1 minus 2, negative 1. Half of 3, 1.5 minus 2, negative 0.5. And half of 4, 2 minus 2, 0. Now graph these. Okay, plot these points. 0, 3, 1, 1, 2, negative 1, 3, negative 3, 4, negative 5. You okay with the first line? Okay. 0, negative 2, 1, negative 1.5, 2, negative 1, 3, negative 0.5, and 4, 0. Which ordered pair appears in both tables? Okay. What do we call this point in terms of the system? Solution. It's the solution to the system, right? What do we call it in terms of the graph? The point of intersection. You okay so far? So when the equations in the system can be blank, then the blank to the system can be described using the blank of the blank of blank. When the equations in the system can be graphed, very good, then the solution to the system can be described using the coordinates of the perfect point of intersection. My favorite question? Why? Why is the solution described as with the coordinates of the point of intersection? They are the only coordinates. What'd you say? That make both. Can I say equations true? Will that work? Any questions about that? Then let's do some examples. Okay? Let's do these two examples right here. Use the slope and intercept of each linear equation to generate the graphs, then state the solution. How do I graph this? You want to do that? By the time you turn your calculator on, get a graph open, start putting this in, I'll be done. Okay? So let's not go, and it says right here, it says use the slope and the intercept. What's the slope of this line? 3/2, and what's the intercept of this line? Which intercept is it? The y-intercept. So along the y-axis I go 2. Then where do I go from this point? Up 3, right 2. Up 3, right 2. God bless you. From this point, can I also go down 3? As long as I go backwards 2, right? So how do I graph this line? Start down 1 on the y-axis. Good. Rise 3, run 1. Rise 3, run 1. Can I fall 3 from this point? As long as I run backwards 1, right? So tell me, where is the solution? Two, 5. Is that the solution? How do I know it's the solution? It's where they cross. 2, 5. Done. Questions? Okay, let's do number 2 then. How do I start? 7 where? Up 7? And then? Down 2? Right 3. Down 2, right 3. Could I go up 2? as long as I go left 3. How do I graph the other line? Start down 3, up 1 over 1, to the right or left? Because I rise 1, run 1, right? Somebody who didn't tell me a second ago, tell me what the solution is. 6, 3, because it's where they cross. Okay? So you have 3, 4, 5, 6. Got it? Now, I put this next page in here for 2 reasons. Okay? The first reason is because all of these 3, 4, 5, and 6 are all y equals. All of them. Every single one of them. Is everything single line you're going to have to graph y equals? No. So I put this page in here because none of these are y equals. This page also tells you how to calculate the intersection on your calculator, except it's the old calculator. So we'll talk about the calculator in just a second, but I would like you to do number 7 so that you can practice getting them into y equals. That's all. Okay? Okay so far? Okay, go to the last page, please. Let's get some notes from the last page. These notes deal a whole lot with vocabulary issues. And it's not really issues, it's just I want you to know some vocabulary. Okay? Some of these words you're going to know from different situations, not math. But I need you to understand they have a math meaning also. Okay? So, tell me what kind of lines these are. Parallel. Now, I'm not talking a whole lot about these today, first of all, because we talked about them yesterday, didn't we? Okay, we talked about these 3 were the 3 possibilities if we were graphing a system of 2 variables and 2 equations. Okay, so that's kind of why I'm just jumping right into these. Fair enough? Okay, if these lines are parallel, what type of system is this? It's called an inconsistent system. Okay? So, Paige, if you were inconsistent on the basketball court, what would coach say to you? Probably sit the bench, right? If you were inconsistent on the basketball court, you'd be sitting the bench because he couldn't count on you to make a shot when he needed you to make a shot, or to pass when he needed you to pass, or block when he needed you to block, right? Inconsistent, how many solutions are there? None. Okay? The one solution that coach would have is to sit the bench, right? But when we're talking about actual solutions here, there's no what? There's no intersections, and so there are no solutions. Sometimes the empty set is used to describe the solution. So sometimes when you get situations like this, and I ask you how many solutions there are, you can just draw the empty set symbol instead of writing the really, really long answer of no solution. Okay? Are we okay with this? Okay? Tell me about this one. The lines what? Intersect. Robert, I couldn't hear what you said. Okay, you're talking to yourself. Sorry. I didn't mean to interrupt. What type of system is this? Why do you say consistent? Because the last one's inconsistent and they didn't cross, and this one crosses, so maybe it's consistent. That's a very, very wise thing. Okay? And in fact, it's correct. It's using your context clues, right? Okay? How many solutions are there? One solution. And it is represented by the We're going to say point of intersection, but absolutely right. I keep making you say point of intersection and not just intersection because some people keep forgetting it's a point, and I don't want you to. Okay? If the two equations in the system graph into lines which intersect at a single point, then they are called independent. They are independent of each other. They meet in one place, but that's all. Okay? Questions? So what about the last column here? The lines overlap? That's a good word. Copycat is also a funny word. How about this word? Have you ever heard of that word before? Coincide. C-O-I-N-C-I-D-E. Coincide. Okay? What type of system is this? Persistent is not correct, but it's a good guess. It does rhyme. This is consistent. Why'd you say that, Kelsey? Why'd you say consistent? Because there is an intersection, right? This one has an intersection. This one does too. It's just the fact that every point is an intersection, right? Okay, very good. So what type of solutions are there? How many solutions? How about if I spell it right? Is that okay with you guys? An infinite number of solutions, or every point on the line. Very good. If the two equations in the system have the same graph, then they are called, very good, dependent. Okay? Any questions about this? So let me show you an example of one of the problems, because there's 6 here at the bottom of the page. Okay? Let me do number 11 for you, or with you. How about that? Because it wants you to find it on graph paper or on a calculator. Okay, well, you guys want to do everything on the calculator to begin with, so let me show you how to do this one. Deal? Okay. First thing I want you to do is listen to the bell. Okay. Let's start a new document. What? Mine is fancy. I'm a teacher. You know how rich I am. Yeah, I won this. That's why I have it. Yeah, I know. You're like, what kind of place do you get to go that you win calculators? I want to go to that. Okay, let's make a graph. Now, this is already pulled up. If it wasn't pulled up, what would I press to pull it up? Tab. Do you remember that? Okay, so let's put this in here. 2x plus 4 and hit enter. And when I hit enter, it does go away, doesn't it? So what do I need to press to get it back up? Tab. And I need to put in the second one. Y equals 1/3 x minus 1. Okay. So the first thing you know is, what type of lines do I have? Intersecting. What type of solution do I have? If it's intersecting, it's this column, don't I? Excuse me, isn't it? So I have consistent, and I have independent, and then it wants to know the type of solutions. Do I have one, no, or infinitely many? One. And then it says, if the solution exists, tell me what it is. State it as an ordered pair. So watch for just a second, please. Okay. Where do you think I should go if I want to try to find the intersection? Where do we always start? Menu. Where do you think we ought to go? I could look at the table. Okay, I could look at the table and see which point appears on both tables. I could trace and see if I could maybe get it to match up, but look what happens when I press Analyze. Look at number 4. What does it say? Intersection. Okay, now look real quick up here. Please watch. I need to scoot my little hand over. Can you see on my little hand that there's a dotted line with that? And down here at the bottom it says lower bound. Well, I need to move this to the left-hand side of my intersection. Is it on the left-hand side of my intersection? Then I click my mouse button. This changed. Now it says upper bound. So I need to scoot it to the right-hand side of my upper bound, of my intersection. And look what it did when I did that. It highlighted it, right? So when I press it again, it tells me my intersection right there. -3, -2. -3, -2. Any questions about that? Okay, so that does 2 things. It leaves you 10 problems for homework. The 4 from the graphing page, and then 1 number 7 on that page, and then 5 from this page. And it also leaves you about 10 minutes to use your calculator to find these solutions. Okay? Any questions? I'll show you in just a second. Is that okay? Are there any other questions? I'm going to show her how to do the intersection again. Any other questions?